Okay. All right, so our topic today will be logarithmic equations. And namely, solving logarithmic equation. So what is a logarithmic equation or a log equation? An equation with a log in it? Well, kind of. Because if I have an equation and I say, log base 2 of 8, that doesn't necessarily make it a logarithmic equation, because log base 2 of 8, I can find a numerical value. That's a constant. So a logarithmic equation is an equation containing a variable in a logarithmic expression. So not only does it have to contain a log, but it has to contain a log with a variable. So example, we said log base 4 of x plus 3 is equal to, this would be a logarithmic equation because you have a variable there. Or something like this, where you have natural log of x plus 2 minus natural log of 4x plus 3 equal natural log of 1 over x. This would be a logarithmic equation as well. Now, on the first one, you only have a log on one side of the equation. Whereas with the second equation, you have a log on both sides. So kind of the same thing with the exponentials. We started off and we solved exponentials where there was only one exponential on one side of the equation, and then we expanded that so that we had exponentials on two sides. So what are our steps? So to solve a log equation, first thing we want to do is we want to express the log in terms of log base b of m is equal to c. So we need to get the log by itself. So isolate our log. To solve a log, write it as an exponent. Solve an exponent, write it as a log. So to solve a log, step 2 is to rewrite in exponential form. Now remember, a log equals the exponent. So in this case right here, my base is b, c is my exponent. So to rewrite this in log and exponential form, it's b to the c is equal m. A log equals the exponent. There's your base. B to the c is equal to m. Step 3. Solve for the variable. And so once we rewrite it in exponential form, then we're going to solve for the variable. We spent the last 2 days solving exponentials. Step 4 is really important because logs, the domain of a log all values of x that are greater than 0, we have to make sure that we're not taking the log of a negative number. So we don't want any false solution. How many of you have heard of the word extraneous? Okay, so we don't want any extraneous or false solutions. So we will need to check our solutions. So we will need to check the solutions. Keep in mind that m has to be greater than 0. You check it by plugging your solution back into the original equation. So good question. So check the solution. You're going to plug into the original log equation. So the example that we started off with up here, log base 4 of x plus 3 is 2. Let's solve that one. Okay, so this one's already written in the form of log is equal to something. Step 2 says rewrite this as an exponent. So here, if we have log base 4 of x plus 3 is equal to 2, rewriting this as an exponent, well, where's our base? What's our exponent? So 4 to the second power is equal to x plus 3. Okay, now where do we go from here? Solve for the variable. So step 1, express it in a log. Log is equal to a value. We have that. Rewrite it in exponential form. We did that. Step 3, solve for the variable. So what do we have? 16 is x plus 3. So what's x? Subtract 3, you're going to get x is equal to 13. Okay, now, are we satisfied that that 13 is a solution?
No.
Okay, so what do we need to do with it? So if we substitute the 13 in here, right, we're going to get, so we always want to check our solution, especially with the logs. Log base 4 of 13 plus 3 is equal to, so log base 4 of 16 is 2. Is that a true statement?
Yes.
How do you know?
Because 4 to the second power is 16.
Because 4 to the second is 16. Okay, so that's true. So we do have a valid solution there. Okay. All right, now this next one, I want you guys to try on your own. Any questions on this one, though, before we go on? Yes?
When we write our answer, do we have to write the 4 to the power 16?
Well, so when we solve this, our answer was 13. Okay. Now, from this point, we have to go to step 4 and we have to check it. So here, if you're able to do this part in your head, that's fine. Just as long as you do take the steps to check to make sure that you have no false solution.
So in the end, we just have to write 2 or false?
Well, yes and no. If it's a multiple choice, let's say you had 2 possible solutions, and one was like 13 and like 5, right? Your multiple choice distractors may be 13 and 5, it may be 5 only, it may be 13 only. So if you don't check both, you may end up getting the problem wrong because one of them may be a false solution. So you don't necessarily have to write true. On non-multiple choice, when I'm grading your quizzes, I'm going to be looking for this. So if you do not go back through and check, I am going to take off a point there. Yes?
It'll tell us though, right? Like on the quizzes, like multiple choice.
No.
It'll tell us like look for true or no?
It will not. So the question that EG asks is, will it prompt me to look for an answer or to check an answer? And the answer is no. You have to do that on your own.
But will it say like look for true solutions or will it say look for
No. It would say find all the solutions. So you may have 2 different possible solutions. You won't know that they're solutions until you check them. You don't check them, your possible solutions may not be a solution. All right, so here is our next one. Okay, so our next one is 3ln 2x, and that's equal to 12. 3ln of 2x, and that one's equal to 12. All right, so ladies who use the power rule, got to be a little careful. So if we use the power rule, so using the power rule, we rewrite this as natural log of 2x to the third. So both of those terms have to be raised to the third power, and that's equal to 12. So now, writing this as an exponent, you're going to get e to the 12th is equal to 2x to the third. Or e to the 12th is equal 8x cubed. Now we have to divide by 8 and take the cube root to get an answer. That's a lot more work, right? Than just, I mean, it's numerically it's going to be the same answer. We would divide by 8, and you'd get x cubed is equal e to the 12th over 8. And then now we would take the cube root of both sides. So you're going to get x is equal to the cube root of e to the 12th divided by the cube root of 8. By the way, the cube root of e to the 12th, just think of e to the 12th to the 1/3. So 12 times 1/3 is 4. You get e to the 4th. Cube root of 8 is 2. Okay, which one of those methods was easier? First one. First one's a lot easier. All right, so when you guys are doing your homework, make sure that we divide through. Huh? Yeah, so here, this one I'm not going to do it. It is because it's not going to make it negative. The only thing you have to worry about is if you're taking the log of a negative value. Because this is positive, when I plug it in here, it's still going to be positive. All right, so let's take a look now. Okay, log expressions are defined only for logs of positive real numbers. So log expressions are defined for logs of positive real numbers only. So because of that, you have to always check solutions. Into the original log equations. So basically, you just want to make sure that you're not taking the log of a negative value, because it doesn't exist. So does that mean, though, take a look at this example. So log base 2 of x plus 20 is equal to 3. So here you already have the log isolated. There's no coefficient. So in this case, all we need to do is write this as an exponent. So if log base 2 of x plus 20 is 3, then this is 2 to the third power is equal to x plus 20. 8 is equal to x plus 20. So we're going to subtract 20, and we end up with x is equal to negative 12. So my question to you is this, can the answer be negative?
Yeah. I mean, if the log is not negative,
So the only thing that we're concerned with is that our log isn't, that we're not taking the log of a negative value. When we plug this negative 12 back into our original, we get log base 2 of negative 12 plus 20 is equal to 3. Log base 2 of 8 is equal to 3. 2 to the third is equal to 8. That's a true statement. So yes, our answer can be negative. In this case, here our answer was negative. We just have to make sure that we're not taking the negative log. So how do you write your solution? So our solution set in set notation is this. Our solution is negative 12. I'm writing it this way just because on some of the quizzes, you may see the solution written this way. So that's our solution set.
Would I write it as like bracket X in the bar and then
No. Because that, if you write it that way, then it's the bracket, the bar, it's X, and then such that X equals 12. You get the same thing from this. So this is the set of solutions. My set of solutions is just negative 12. If there were another number in there, then I would put that first number, comma, the second one. So it's not an interval. It's just, here's my solution set. All right. Almost done. Okay, final part of today's lesson. We may need to condense. A log equation to solve. So we may have to condense. So example, we have log base 2 of x plus log base 2 of x minus 7, and that's equal to 3. Now, if you look back at our original steps to solve, you saw we had to write it in the form of log base b of m has to equal to c. And we don't have that here. We have 2 logs. So we're going to need to condense this. So what would the condensing of this look like? Log base 2 x times x minus 7. Remember, the log of a plus the log of b is the log of a times b. So that's our product property. The log of a plus the log of b is the log of a times b. Now you have the one single log. So our next step would be to write this as an exponent. 2 to the third is, and I'm going to multiply this out because you are going to end up having to factor. If we subtract 8 on both sides, so here we have x squared minus 7x is equal 8. Subtract 8, x squared minus 7x minus 8 is equal to 0. So what are our 2 solutions? So x and x, so minus 8, right? And plus 1. So x minus 8 times x plus 1. That's the x squared minus 7x minus 8. So your two solutions, we have x minus 8 equals 0. X plus 1 is equal 0. So here we're going to get x equals positive 8 and x equal negative 1. What other one? Okay, so what is your solution set? Is it 8 and negative 1? Is it only 8? Is it only negative 1? We have to check. We have to plug it in to our original. So, at x equal 8, we have log base 2 of 8 plus log base 2 of 8 minus 7. Is that equal to 3? What's log base 2 of 8? 3? Log base 2 of 1. 3 plus 0 equals 3. So that's true. So 8 is a solution. Uh-huh. Plug it into what?
To your x squared minus 7x, or minus 8.
Right here? Right here. No. No. Because it's going to be true. We just solved it. We already know it's true. No. So at x equal negative 1, we're going to get log base 2 of negative 1. We can actually stop here. Plus log base 2 of negative 1 minus 7 equals 3. Here, the log base 2 of negative 1 does not exist. So this is no solution. You cannot take the log, regardless of the base, of a negative value. No. If you assume that, then you will find the case where both the positive and the negatives are actually true. And a lot of students will do that because you'll do 10 problems in a row and the negative one is always never a solution. And then on the test, some sneaky teacher is going to give you a problem where the negative one is a solution and you're going to get it wrong because you didn't check. And you know that all teachers are sneaky, right? Okay.
We could plug in like x equal 8 and x equal negative 1 to log base 2 of
The original.
But we could also, what about the, can we just plug in log base 2 of x squared minus 7x and then that work out? That's the condensed numbers.
So if you plug it in here, so if you plug a negative 1 in here, so you're going to get negative 1 times a negative 8. So you're going to get negative 1 times a negative 8 is a positive 8. And you're going to get log base 2 of 8 is 3, which is true. So you cannot plug it into that one.
So how does it not remain true if it's condensed?
It's not. Okay.
No, not true, but like
I will say it one more time. Plug it into the original.
Why thought they were the same thing? Because it's just condensed.
Plug it into the original.
It's a lie.
All right. You guys are just dying to get problems wrong on the test. I'm telling you to plug it into the original. All right, here we go. Okay, last part. Just like exponentials, logs are one-to-one functions. They're one-to-one. So, ln of x plus 2 minus ln of 4x plus 3 is equal ln of 1 over x. Okay, we actually, at this point, because these are one-to-one functions, I can just equate the values. Same thing with e. When we found the same bases, we just set the exponents equal to each other. We can do the same thing here. So I don't have to write it as an exponent. But what I do need to do is condense this one. Log of A minus log of B is log of A over B. And that's equal to the natural log of 1 over x. Now, because these are one-to-one functions, I can set these two equal. X plus 3 over 4x plus x plus 2 over 4x plus 3 is equal 1 over x. And now that's what we need to solve. Cross multiply, well, I guess what you said is fine. You said multiply both sides by x?
That's what you're doing.
Yeah, that's what I'm doing. So I'm going to get x squared plus 2x equals 4x plus 3. They're one-to-one functions. Remember what we said? They're one-to-one functions, just like exponentials.
So that's going to equal that.
Yeah, because it's a one-to-one function. So in this example here, I had a log equal to a number. So I couldn't just take the log away. If this were log base 2 of this is equal log base 2 of that, then I could take the number away. I can't do that here. Here I can. I have a log equal to a log. They're one-to-one functions. All right, so x squared minus 2x minus 3 is equal to 0. Where did I get that? Right? So here I subtracted 4x and I subtracted 3. See how important factoring is so far in this course? It's a lot. So what are your two solutions? X is 3 and x is negative 1. Plug it back into the original. But you can see when you plug in negative 1, you're going to get natural log of 1 divided by negative 1, natural log of negative 1. So the negative 1 is a false solution. So this is extraneous. But what about the 3? So at x equal 3, we get ln of 5 minus ln 4 times 3 is 12 plus 3 is 15 equals ln of 1 over 3. Is that a true statement? Is ln of 5 minus ln of 15 equal to the natural log of 1 over 3? ln 5 minus ln 15 is ln of 5 over 15. So ln 1 over 3. What is 5 over 15 reduced? 1/3. So that is a true statement. Yes.
Are we going to have any where it's just not true because they don't equal each other?
If you go through this process and you solve, you should not. No.
So just because it's going to be a negative.
Right. So the question that EG asked was, are you ever going to have any of these so that when you go through,